Let's have a look at how we can determine whether we have a GPU to render with in Blender. So if we go up to Edit Preferences, we can go down to System. I'm using a Mac, and it's a pretty well-spec'd, fairly new computer. So we can see here that it supports Metal, which is a Mac-specific rendering technology. If yours says CUDA or I forget what some of the other technologies are off the top of my head that support NVIDIA or Intel or whatever, you'll see different options. But you should see, if you have some of those options, a GPU listed, and it will say GPU next to it. You want to tick that on if it's ticked off, and then you can have access to the GPU compute drop down over here. You don't want to turn on both the CPU, which is this right here, Apple M3 Max. The CPU can sort of, I don't know exactly how it works, maybe pretend to be the GPU in this case. You don't want to use this in conjunction with the GPU. Number one, I think it will actually go slower. And number two, I believe it will render your images slightly differently. So you will get different looking renders depending on which processor, either the CPU or the GPU, was doing the work at the time. So just stick with one, either a CPU or a GPU. If you have a GPU, turn it on. It should be faster. And this is how you do it. So I want to quickly talk about rendering in Blender and how to optimize your scenes. So I have downloaded and opened up a demo file hosted on blender.org. And on the right in our settings, you can see that it's currently set to cycles. It does recognize a GPU, which will be faster than a CPU typically to render. And then under render settings, we have max samples set to 600. So if I go to render image, let's just see how long this will take to render. So first it has to load everything before it begins rendering. So we're going to see some of that process get set up here. Okay, so you can see this loading information. So it hasn't even really started rendering yet. It's still just loading. And this happens the first time you might be trying to render a particular scene. This scene is probably pretty complicated, so your scenes likely won't have this long of a load time. Yeah, and it even has a message here. This is typically for Macs, where it has to load render kernels. Not totally sure what a render kernel is, but it needs them to render. So once those are in, there we go. Now we can actually start the rendering process. So what we'll see is frame 0 being rendered here at the top left, the time. It estimates that it will be about 4 minutes to complete rendering. The amount of memory that's being used, this is quite a bit of memory. This looks like it's about 7.5 gigabytes. So there are ways to optimize your scenes to use less RAM. If you ever run into errors, it's because you're probably running out of RAM and your scenes are too complicated. You can see here on the right, we're on sample 96, 112 of 600. So basically, this is how many iterations of samples it's taking at one time. And so when this ticks up to 600, it will just stop rendering. 600 is typically high enough to eliminate noise. Typically what you want to do is balance render time with the amount of noise in a particular scene. With denoising technology, you can have noise in your final render, and Blender will do a denoising step where it essentially removes some of this grain that you're seeing here in the image. So this is a pretty heavy scene. I am going to stop it. We don't need to render all the way to 600. So if I go down here and click on the X it will cancel the rendering. It's going to take a second. And if I just want to open that window back up, I can go up to Render, View, Render. And then this will just bring that window back. So it has some stats here. We rendered for almost 2.5 minutes. And I want to just kind of go through what you can do or the impact that these settings have. This might be pretty optimized. What I'm going to do is go to slot 2. And slot 2 is just a different place to render to, and it won't overwrite slot 1. So with slot 2, I can now do a different render and we can compare between the two. So if I was to do max samples of, let's just do 25 samples. It should look pretty rough. Let's go ahead and render with 25 samples. Okay, now it has to reload a bunch of the mesh data and other types of data, but it already had those kernels loaded from earlier, so we begin rendering much quicker. And it looks like we are done at 25 frames a second, but you'll notice we don't have noise. And so why is that? If we go to our compositor, that's actually not, so if we go to the view layer, so it's a little bit confusing what this is doing, but essentially this is giving us a view at different things that were rendered. So for instance, if we go to our composite, this is the final image. And if we switch to view layer, it gives us this other drop down. And we can see we've got combined, depth, and noisy. If we go to noisy image, now we can see what 25 samples looks like. It's pretty bad compared to slot 1, which I have to switch that back to view layer. So this is slot 1, some noise. Slot 2, lots of noise. But you'll notice that when we go to combined, it's taking, essentially it's creating a new image that has been denoised. And that is with this denoise setting down here on the right. So you can actually turn that off if you don't want it. You don't have to use the denoiser. And it is optional, but it doesn't typically cost much time in the rendering process to add it because it's a step that occurs at the end of the process. But for still images especially, denoising can really help your render times. You have to be careful in animations because sometimes it will blur things out and makes things appear to be smudged. And this will be very apparent in an animation. So you want to do animation tests where you're seeing whether denoising makes sense to use and whether it's creating distracting and noticeable artifacts in your animations. So that's the effect of denoising. But this image arguably looks much better than this image. And I guess the argument could be made that this image does not look as good as this combined denoised image here. We do lose a lot of detail in the couch, so 25 samples was not very much. Let's take a look at what happens though when we switch to CPU. Okay, I'm going to take this back. Actually, let's leave it on 25 samples and see how long it takes to do 25. So if I go to render, view render, and we go to slot 3, so we can see here it took 21 seconds to render 25 samples. If we go to slot 3, we're going to put our new render here. So if I go up to render image, remember we switched to CPU. So now we're going to see the difference between a GPU and a CPU for rendering. Okay, we're on sample 2. Sample 5. Okay, by this time, using the GPU, we were already done rendering our 25 samples. We're not even halfway done. So a GPU renders more than twice as quick on my computer for this particular scene. Okay, still going. We're at 40 seconds. $25 seconds, or sorry, 19 seconds. And 25. So it looks exactly the same, of course, as slot 2 because it rendered to the same amount of samples. Actually, there are slight differences. A GPU and a CPU, they're different processors, so you do get different results. So we'll notice there's some lighting differences here. There's something that maybe isn't compatible with the CPU that was used on the GPU. If you look up here, we have this dark line. So that's really strange. And then we have some difference in the reflectivity here. So other than these differences, it's largely the same image. However, it took 1 minute and 4 seconds versus 21 seconds using the GPU. So there's a big advantage to use the GPU with this type of rendering. So hopefully that kind of helps demystify what's going on with the rendering. But essentially, a sample is related to the calculation for each pixel, and the more samples, the more accurate your scene is going to be rendered. So you can use a balance of changing to GPU if you have one, lowering the samples, and using the denoiser to get better quality renders from your scene.